Alright, 4.1, example 8. In this example, we're going to solve the triangle. We're going to round any side lengths to the nearest tenth and any angle measures to the nearest degree. So first I want to identify and define what solve really means. So to solve something means to find all the missing sides and missing angles of a triangle. So in part A, we're given this triangle. We have one of the angles, we got one of the sides, and we need to find the other missing angle and the two missing sides. So the way I like to start this off is just by writing everything down. So I'm going to write down the word sides, and I'm going to write the word angles, and then I'm going to write my sides are x, y, and z, and my angles are angle x, angle y, and angle z. And this way, I just write everything down, and then I can't miss anything. Then what I like to do is fill in the information I know. I know angle x is 35 degrees, and I know angle z is 90 degrees because of the 90-degree symbol right there. I also know side y is 10. So now all I gotta do is start finding the missing pieces. Well, if you add up all of the angles of a triangle, we get 180 degrees. So 35 degrees plus angle y plus angle z is equal to 180. So 35 plus angle y is equal to 90. And so angle y is equal to 55. So angle y is 55 degrees. Easy. Now we got to find x and z. So in order to do that, we just got to set up our trig functions. Well, this is my angle right here, and you typically want to use the angle provided, not any angles you solve for. So this is angle 35 degrees, which is angle x. So I'm going to use tangent in order to solve for this. So I get tangent of 35 degrees is equal to opposite, which is x, divided by adjacent, which is 10. So then I multiply both sides by 10. And I get 10 times tangent of 35 degrees is equal to x. You put that in a calculator and you're going to get about 7.0. So then my side length for side x is 7 when rounded to the nearest whole number. Or really tenth, but same thing for this one because it's 0.0. Okay, now for the next one, I need to find z. So now my goal is to find this, but I still want to use this 35-degree angle, so I'm going to use cosine. So I get cosine of 35 degrees is equal to adjacent over hypotenuse. So the adjacent is 10, and the hypotenuse is z. So I'm going to multiply both sides by z. And I get z times cosine of 35 is equal to 10. So then I divide both sides by cosine of 35 degrees. And I get that this is z is equal to 10 divided by cosine of 35. And you put that into a calculator and you're going to get z is approximately 12.2. So z is approximately 12.2. And that's it. You're all done. All you had to do was find all this information, and that's it. All right, let's try another one now. We're still going to do this one together. This time we're given two sides and only one of the angles. So the first step I like to do is write down sides and angles. Okay, so now I'm going to fill in any information I know. Well, side L goes with the side that's across from the angle. So this is 8. Side J is 11, and we need to find K. And then our angles, we know angle K is 90 degrees. So this time we're actually looking for the sides, but we don't need to use a trig function, we can just use the Pythagorean theorem. So we have that a squared plus b squared is equal to c squared. And in this case, I don't know c. I know a is 11, and I know b is 8. So I get 121 plus 64 is c squared. So c is equal to the square root of 185. So I can just put that right here for k. Call it a day for that. Now I need to find the angle. So what I'm going to do now is I'm actually going to solve for angle J. So let's go up here. And angle J is this one right here. And so I'm going to use this 11 and that 8. So this is my opposite when I'm looking at angle J. And this is my adjacent. So because we have the opposite and adjacent, we're going to go ahead and use tangent. So I have tangent of J is the opposite, which was 11, and the adjacent, which was 8. And so now we're going to use our tangent inverse properties to write this as J is equal to tangent inverse of 11 over 8. And then you just put that in your calculator, and you get that the angle J is about 53.97 degrees. So rounding that to the nearest tenth, I get angle J is about 54 degrees. And then we know that all triangles add up to 180 degrees. So to find angle L, I go 54 plus angle L plus 90 is equal to 180. So angle L is equal to 180 minus 90 minus 54. So angle L is equal to 36 degrees. And I'm going to change this to approximately because we estimated for angle J. So 36 degrees. And that's it. All done with that one. Okay, now on your own, I want you to try to solve both of these triangles. Okay, here we go. Let's do A first. So with the setup, okay, so this is what I know. I'm given two sides, so now I'm going to go ahead and find the third side by using the Pythagorean theorem, but be very careful because C is not the hypotenuse. B is the hypotenuse because B is across from that right angle. So we get A squared plus C squared is equal to B squared in this example. So C is approximately 31.1. And now we need to find our angles. Well, we know 90, but we need to find the other ones. So let's start with angle A. We'll start with this one right here. And this is my hypotenuse. And this is going to be my opposite. So I'm going to use sine. And it's opposite over hypotenuse, so it's 20 over 37. And then if I want the angle, I take the inverse of both sides. So 20 over 37. And I put this into a calculator, and I get approximately 32.72 degrees. So rounding to the whole degree, I'm going to get about 33 degrees. And now in order to find the last one, I'm just going to use the fact that three angles add to 180. So I get 33 plus 90 plus angle C is 180. So angle C is 180 minus 33 minus 90. So angle C is equal to 57 degrees. So angle C is about 57 degrees. All right, let's go ahead and do part B. So for part B, it's a little bit different because we're given slightly different information, but I'm going to set it up the same way. So in this problem, I'm given that side T is 35, and I'm given angle S is 90, and angle R is 23. So I have two angles, so I can set it up to find the third. So 23 plus 90 plus angle T is equal to 180. So angle T is 90 minus 23. I just minus the 90 right away. And angle T then is equal to 67. So 67 degrees. Now I just got to find the remaining sides. So I'm going to work with this angle because it's the one I'm given. Let's go ahead and find R. So R, this is the adjacent and this is the opposite. So I'm going to use tangent. So tangent of 23 degrees is going to be equal to R over 35. So then I multiply both sides by 35. And I'm going to get 35 tangent of 23 equals R. You put that into a calculator and you're going to get approximately 14.85. And so rounding to the nearest tenth, I get R is approximately 14.9. And then for S, I'm going to also use this angle right here, but I'm going to use this one and this one. So this is my hypotenuse and this is my adjacent, which means I'm going to need cosine. So I get cosine of 23 degrees is equal to 35 over S. So you multiply both sides by S. You get S times cosine of 23 is equal to 35. Divide both sides by cosine. You get S is equal to 35 divided by cosine of 23. And then you put this into a calculator and you get S is approximately 38.02. So my answer is approximately 38